Okay, today is graphing linear inequalities. The first example asks us to graph y equals 2x minus 3. So we look at the equation and we see that we have a y-intercept of negative 3. So we go to the y-axis, graph the negative 3. We have a slope of positive 2, so we count from the y-intercept up 2 and over 1 to get more points on the line. And then the opposite direction to get the ones on the other side. And it's wanting us to determine where y is less than or equal to the line. Let me go ahead and finish graphing the line. So here we have our line, and we need to determine where y, the values of y, are less than this line. So it tells us to choose 3 points, one on either side of the line and one on the line. So we'll go ahead and choose, let's choose this point here to be on the line. So this is over 2, up 1. So we have 2, 1 is one of our points. And then we will choose, choose this point here. And this point is over 4, down 4, so that's 4, negative 4. And then we'll choose a point over on this side, and since the origin's there, I'll go ahead and say 0, 0, just to make my life easier. So what you're supposed to do at this point is substitute these 3-point values into the inequality. So where y is 2 and x is 1, so is 2 less than or equal to, sorry, should be a 1, not a 2. The y value is 1. So is 1 less than or equal to 2 times 2 minus 3. So that means is 1 less than or equal to 1? And is that true or false? That would be true because it is equal to. Then we have 4, negative 4. So is negative 4 less than or equal to 2 times 4 minus 3? So this becomes negative 4 less than or equal to 5, and that is true. 0, 0. Is 0 less than or equal to 2 times 0 minus 3? 0 is less than or equal to negative 3. And is that true? It is not, because negative values are always smaller than 0. So this one does not work. So what this tells us is that for y less than or equal to 2x minus 3, the line itself and anything that includes that point 4, negative 4, all of this area here is what is less than or equal to that inequality y less than or equal to 2x minus 3. So if we have a line with a shaded area, that part of the graph, any point that is in that shaded area would be a true solution to the inequality. If it's not true, then it's not part of your solution set. So then it says graph this again. So I'm going to go ahead and graph it again. So again, we go to the y-intercept of negative 3. Then we go up 2 over 1 to get more points. Down 2, back 1. And there's that line. And head and shade. And it's asking, what would the graph look like for each of these situations? And this gets a little tricky. For less than or equal to, you would have a solid line, just like when we have an inequality, an open and or closed circle. A solid line is like a closed circle. So anytime you have the equals portion, you have a solid line. Anytime you do not have it, then instead of an open line, we'll call it a dashed line. I'll show you that on one of the other examples. For a less than, you shade below. For a greater than, you shade above. So what that means is when you're looking at this one, for less than or equal to, here's the line, and I want things below that line. So if I look at the y-intercept, I go below that, and I just stay below the line each time. For a dashed line, it's still the same. If it's less than, we shade below. If it's greater than, we shade above. So this information right here looks like a good little short quiz. So I would make sure that I could fill in this information exactly. Now they give us several points here, and they want to know which of these is a solution. So we're going to graph each of them. 1, 0. Over here, start at the origin. I go over 1 and up 0. Is this one in the shaded area? No. So it is not a solution. 4, 8. If I go over 4, 1, 2, 3, 4, and up 8. 1, 2, 3, 4, 5, 6, 7, 8. This one is also not a solution because it's not in the shaded area. For -6 and -2. So we go 1, 2, 3, 4, 5, 6, down 2. This one also not in the shaded area, so it's not a solution. -8, 0 is on the sorry, it's on the y-axis. 1, 2, 3, 4. What am I saying? It's on the x-axis. 1, 2, 3, 4, 5, 6, 7, 8. Go up or down 0. Again, not in the shaded area. So not. And finally, -5, -4. 1, 2, 3, 4, 5. 1, 2, 3, 4. So absolutely none of these would be a solution because none of them end up in the shaded area that we have here. Okay, so on the next half of the page, up at the top, it says solve each inequality by graphing. In order to solve them by graphing, we're going to first solve for y. So on this one, we're going to add 2x to both sides. So we get 3y is greater than 2x plus 6. To get the y by itself, we're going to divide everything by 3. Get y, and then here we get 2/3 x plus 2. And because this is an inequality, we ask ourselves, did I divide by a negative? No. Because I did not divide by a negative, the inequality sign stays the same. So now I can graph this. I have a y-intercept of +2 and a slope of 2/3. So as I go up 2, I have to go right 3. Up 2, right 3, up 2, right 3. So that gives me as far as I can go on that side. So then I'm going to need to go down and left to get the other side done. Now, because this is a greater than, if I look back over to the other side for greater than, I need a dashed line. So to make your dashed line, just take your points that you've got and just put a little bit of a dash through each of those points, just so long as they do not touch each other. And then, of course, put your arrows at the end. So now we have a dashed line. Because it's greater than, go over here and look for greater than, we want to shade above the line. So looking at this line, here's where my y-intercept is. Above the line is going this direction. We show that with arrows like that. This is going above. So what I want to do then is shade all of this stuff in. So that means any point that is in this shaded area is a solution to this inequality. For number 2, again, we need to solve for y, so we're going to subtract x from both sides. So we have negative 3y is greater than or equal to negative x minus 6. We're going to divide everything by negative 3. And because we divided by negative 3, this sign flips and becomes a less than or equal to. Negative 1 divided by negative 3 is a positive 1/3. We put our x real big beside the fraction. Negative divided by negative is positive. So this time we have a less than or equal to 1/3 x plus 2. We have the same y-intercept as the other line, but our slope is different. It's a much flatter slope. So if you were comparing this line and this line, you see that the slope of the second line is smaller, so the slope has decreased. So the overall effect is that this line is flatter. Now because of the equal sign, we're going to have a solid line. I sent Walter down. Is Jason in here? No.
Sorry, thank you.
Okay, well that's going to be interesting on the tape. All right, so less than or equal to means we're going to go below this. Where we see that, we're going to go below. And just shade everything in that's below that line. On number 1 above, it says which of the following would be a solution. So we're going to go ahead and graph 1, 0. So we go over 1, up 0. So for number 1, this is not a solution. 4, 8. We go over 4 and up 8. 1, 2, 3, 4, 5, 6, 7, 8. Is this inside the shaded area? Yes. So it is a solution. Negative 6, negative 2. 1, 2, 3, 4, 5, 6. 1, 2. This one is on the line. It is not a solution because the line is not included because it's dashed. Negative 8, 0. 1, 2, 3, 4, 5, 6, 7, 8. Negative 8, 0 is indeed inside the shaded area, so it is a solution. And then negative 5, 1, 2, 3, 4, 5, and then down 4, 1, 2, 3, 4. This is not inside the shaded area, so it is not a solution. All right, now we have 2 special cases. We've talked about this before. When we have a y and a number, we have a specific kind of line. If it's a y equals or greater than or less than or whatever, y and just a number, then what you have is a horizontal line going through the point where y is 3. Now because this is greater than, what we have is a dashed horizontal line through the point 3, where y is equal to 3. And we want things bigger. So that's everything above the line. But it does not include the line. X less than or equal to negative 4 is a special case when we're dealing with these. This one is our vertical line. So we're going to go to where x is negative 4. And we're going to put because of the equals, we're going to put a solid line through x being negative 4. So this is where x is equal to negative 4, and we want the things smaller than negative 4. To be smaller than negative 4, you need to be to the left of it, so we're going to shade to the left of that negative 4. This line is included because of the equal sign, so the negative 4 is included, whereas on number 4, the 3 is not included because it's strictly greater than. And those are the notes for graphing linear inequalities.